In section 20, we will look at graphing some polynomial functions. The use of the calculator is not allowed in this section. We look at model 1 and it is given to us in factored form. We can see here that the degree is 3, and what we'll want to do first is to graph the zeros. So by setting each of these factors equal to 0, we get -4, 1, and 5. And I'll place those on the x-axis. From here, we determine the behavior of the far right side. That's determined by the lead coefficient. The lead coefficient here is going to be positive. So because of that, it's going to end up. So I know that on this side, the graph is going to be up here. Now from here, since all of these are real zeros and there's no double roots, I will be able to pass through each one of these once as I sketch my graph. And so that's the next thing we're going to do, is sketch a smooth curve that passes through each of those zeros. Now all of ours are going to look a little bit different. This is the exact answer of what it should look like. This is exactly how high and how low those two areas should extend. However, in this class, we don't worry about exactly how high or how low they go in a particular region. So as long as between -4 and +1, you went up in between those two, and as long as you're down in between these two, it doesn't matter how far up or down you went. Because finding the specific height in a region requires a calculus background that we're not going to go into. And you can see here in this statement that as long as you have the correct zeros and you're above or below the graphs in each particular region, you will get full credit for these problems. So here's another example. Again, we're going to find the zeros and we're going to graph them. So when we set x plus 6 equal to 0, we're going to get -6, and that is going to be a double root. When we set x plus 2 equal to 0, we get -2, which is also a double root. We set x minus 4 equal to 0, we get +4. As I sketch these, I want you to indicate on the graph, I want you to put like a little dr by this value and this value. Or the other option is you could circle both of those, indicating that they are double roots. And the reason is because when we graph these, if it is not a double root, if it's a single root, we're going to go through that value. But when they're double roots, we can't pass through them. What we'll do is we'll touch them and then extend the other direction. Next, we determine the behavior on the far right side. And that is going to be positive because the lead coefficient will be positive here. So I know I'm going to be up here. I'll go down through this point. I start to switch directions and I come up to this point. Because we know that this is a double root, we cannot go through that point. So we switch directions. Then I come back up towards this point, and again, I can't go through it because it's a double root. So I touch and we go back down. And so as I actually sketch that, it should end up looking something like this. Again, yours might not have come so far down between these 2 points. Maybe yours came down a little bit further between these 2 points, and that's okay. Just as long as you're above the graph where you're supposed to be, below the graph where you're supposed to be, and that, you know, when they're a double root like this, you show that they're tangent, because it does not cross the x-axis. So what I'd like you to do now is go ahead and do problems 3 and 4, and then we're going to check those in a few minutes. And here's your answer for number 3. So we ended up getting a +2 for this one, and that's going to be a double root. We get a -3 for this one, and we get a +5 for this one. And I will go ahead and sketch these. Again, as I plot those points on there, I want to indicate somehow that this is a double root, either by writing dr by that or by circling that to show that it is a double root. Now when I go to sketch, I know it's going to end up because the lead coefficient is positive. So I went through this point. I come up to this point and I can't go through it. I've got to touch that and switch directions. We go down and then we go up through that last point. And then here's the answer to number 4. We had 4 real zeros here at -6, at -3, 4, and +8. And then I can see again on this one that it's got a positive lead coefficient. So we're going to start up here. We go through this point, we go through the next point, we go through the next point, and through the next point. Again, does not have to match this graph exactly, but just make sure that you're above in the correct regions and that you're below in the correct regions and that your intercepts are the same as they are here. Now if we look at number 5. With number 5, again, I'll sketch -6, -3, 0, and then at 4, I want to indicate that that's a double root. As far as the behavior is concerned, it's going to end up again because this is a positive lead coefficient. So once again, I'm indicating that this is a double root. So I come down and touch this point and I switch directions. But the rest of them I go through and through and through. And this is what that graph should end up looking like. Again, okay if you didn't go up as far here, down as low here, that type of thing. Here's number 6. We sketched those points. Again, indicating that at 0, this is a double root. From here, we determine the behavior on the far right side. Again, because it's positive lead, we know that it's going to end up. So this is going to be positive up here. And then here, I'll go through this point. I come up and touch this point and switch directions. Go through this point, go through this point, and then that should be the graph. For model 7, here I'm going to want to factor this right away, and I can factor x squared minus 5x minus 6, but I am not able to factor x squared minus x plus 4. This part right here, if I test it, I'm going to find out when I do b squared minus 4ac, I would get 1 minus 16, and that's going to give us a negative number. That means that that's going to represent 2 complex solutions for this part. So now we can kind of ignore that this part existed. We won't be able to really show how that would be graphed in our graph. So now we find that the zeros here, the real zeros, are at negative 1, 3, and 6, and we'll plot them accordingly. From here, again, I know that it's a positive lead, so it's going to end up. And then I will be able to go through each of those because I don't have any double roots. So I extend from up here, I'm going through this point, and through this point, and that should be what my graph ends up looking like. For number 8, do the same thing. We're going to try to factor if we can. And when we factor, these are the factors. Again, we want to look at this set right here that is not factorable, and we're going to try to find the discriminant of that. When I go to do that, I do get a negative number. Because I'm getting a negative number for that, that means that this part is complex, which again means that I can kind of ignore that in terms of the graph that we're going to come up with here. We're going to then find our zeros. Our zeros here will be at negative 4, 0, and 2. We do want to make sure we're aware that negative 4 is going to be a double root. So I plot those 3 points again, making sure that we remember that this is a double root. So indicate that somehow on your graph. Now I look at my lead coefficient. Again, it's positive, so it's going to be up in this region. Then what I'll do is I'll go through this point, touch this point, and go back up, so that our graph ends up looking roughly like this. Again, because it's got that complex piece, that's why we have this curvature happening right here, but it's okay that you don't have that in your graph. Yours is just going to go down and up through that point. For number 9, do the same thing, try to factor. When we factor, the first 2 sets of parentheses are factorable, the last one is not. Again, if I test the discriminant of that, it is going to come out negative. Therefore, that part's going to give me complex solutions. So although this is going to be a 6-degree polynomial function, 2 of them are complex, that we can kind of ignore that in terms of what we're going to be able to come up with. Our zeros will be at negative 5, negative 2, and then at 6, but that's a double root. So now I'll sketch those. Again, I want to keep in mind that this right here is a double root. From here, my lead coefficient is again positive. That means it's going to end up. So if I'm up here, I touch this point and I switch directions, then I go through this point, and then that should give me my answer. Again, yours is not going to look exactly like this. We touch this point, yours might have just gone straight up in the middle and straight down, and that is completely fine. Again, you don't have to worry about how high or low we are in each region. For this one, do the same thing, attempt to factor. Once we factor, this is what we should have come up with. Once again, we have this part right here that we're going to test to see if it's complex, and it will be. When we do 0 squared minus, this will be 36, so it'll give a negative 36 here, so we're going to kind of ignore this part. Then we're going to come up with our zeros. Our zeros are at negative 7, negative 4, negative 1, and 3. I'll plot them accordingly. Lead coefficient is positive again, so it ends up. And I don't have any double zeros here. So I can go through every single one of these points. It's going to go through this one, through this one, through this one, and through this one, so that it looks like this. Again, at the end, because this was an even degree here, it was a 6 degree, I do want to make sure that these are extending both the same direction, that they're both extending up. Now for homework tonight, you are going to work in practice set 20. So please follow the directions that you're given in class and complete those assignments.